Once we've identified the hash code for an object, it really unlocks some great ways we can use that in helping to sort data structures. Because remember, the hash code becomes a really quick and simple way to reference into things. We can use the hash code for either a set or a map. The hash code becomes in a map the key to where we're going to look it up. In a set, it becomes a easy way to compare two objects to see if one's greater than or equal to each other, and then a quick way to look them up accordingly. So the first thing that's really important to understand is how we identify the equality of complex objects. So if we say, how do we know if two students are the same or not? There's a number of things we could look at. So we could say, do they have the first and last name? Well, I mean, there are more than one Tony Lowe in the world. That last statistically count I saw, there was like 75,000 of us. Um, Email is probably unique, but who's to say that some future student could end up with a similar email? We try and make them unique, but email could be replayed. So really, student ID is assigned explicitly to be a unique identifier. Sometimes, like you come back later on, if you were registered in the system, your student ID stays the same because they track it by your first name and last name. But I could also reassign you a student ID at some point in the future. It's just a number to track. It doesn't mean anything. Um, so if we go to a little bit more complicated example, if we talk about a course, how do we know if a course is unique or not? Well, there's a lot of ways I could do here. So we do have a course ID, like CSC 101, CSC 592, CS 85, IT 52, some ID that we assign to it. But if I'm looking for a course I want to take, I might be looking for that ID. I also need to talk about the term and the year it's going on. So I want to take, IT 101 in 2020 in the spring or the fall or the winter, as opposed to the class that happened last year in 2019 or next year in 2021, or if this video is out there for many years, then I've dated myself on what year I've talked about. Um, so it's also possible, if I want to talk about what class you're currently sitting in, that the section matters as well. So if I want to manage active enrollment, I need to know the ID, the year, the term, and the section. So again, I could always create a unique identifier for any object, but sometimes there could be multiple unique identifiers that I want to talk about. In one case, I want to talk about specifically which section I'm talking about. In other cases, well, what course, year is being taught. In other cases, what are all of the courses by this course ID? Every year, every section, everything else. Anybody who's ever taken this course before? So one more example, we have vehicles out there. Every vehicle has a VIN. We have a big long code that gets stamped onto the dashboard, put in different parts and whatnot of a vehicle. It's like every computing device, everything with a chip has a MAC address that's associated with it. It's supposed to be unique to it. But again, if I say, well, do you and I drive the same car? Well, we literally can't drive the same car. We'd have to have the same VIN. One of us would have to share it with the other. But we could have the same car because we have the same make, model, and year. So if I want to find a vehicle to buy, well, what car do you recommend? Well, I really like the 2019 blah 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 blah. Um, that is a good recommendation for you to buy the same vehicle I bought or the same vehicle I test drove or drove as a rental car, or however I decided I like that car. And notice it's not necessarily just the make and model. I mean, the 2019 might be great, the 2017 might have sucked. So there's all sorts of data items we might want to compare, and that might change depending on the question that we're asking. And so the VIN number is inevitably unique to an object, but equality doesn't not necessarily mean an object. If we're talking about the same object, there's always an easy way to do that inside of a program. So I just look at the memory address that's stored. But I do want to talk about more nuanced stuff that when we're talking about the design using maps in particular, and sometimes sets as well. So you got to remember, the rule of a set is I have a single group of unique values. And so hashing's main purpose in this is to get us quickly to whatever, whether that value exists in my set or not. So if you remember, hashing chunks everything into groups. If I have my 52 cards and I say do you already have this card in your deck? Let's say I lost some cards and somebody's giving me new cards from another deck. They're not literally the same card because I lost the first one, but the same suit and order of the card helps me identify if I have enough cards to play the game. If I need one of every card. So if I want to quickly search that list by chunking it into 4 groups, I can immediately cut the number of cards I'm searching for in a quarter, and that makes my life faster. As far as maps, it's also really, really good to help me chunk it and sort it through that area. But the great thing about maps is it lets me also blend the way I store data because I have a key and a value. So the key could be one type of data, the value could be a different type of data, and so I can use multiple maps to represent the same type of the same data in many different quick sortable ways. So sets are just simply saying I have one of each of these things. Maps, I don't necessarily have to have one of each of these things, but I have one way of organizing each of these things. So let's take a look at that and how we can do that, use that in interesting ways. So, for example, let's say I gave you a survey, and in the survey, you can have a bunch of responses. And so each ID, as we can see up here, is a different unique person that responded to a survey. And their responses, they could have been very interested. They could have been, it may be useful. They could be not sure. They could have a number of responses inside of there. Um, so I can use maps, by the way, sometimes called dictionaries as well. I can use them as a way of categorizing and counting data, if you will. So I have 1, 2, 3, 1,000, 10,000 that come in. Well, what I can do is I can look at the response and I can look up in a map, and every time I find one of those, I can tick up my count for that structure. So I could have 100,000 responses here, but I can take each response and throw it into its own category. I can have the key be the response value, and the value be an integer, which counts those things up. So let's talk about some other challenges of how you can organize data within a map. So for example, we go back to our vehicle object. Let's ask some questions about this. So how can we figure out, if we have a list of cars coming in, all the cars that were sold in a year, how many cars of each type were sold each year? So how many 2020 Ford Escorts, I don't even know if the Ford makes the Escort anymore, were sold in any given year, plus every other different type of car? Again, I have a whole bunch of data. How do I sort that out? Well, we just saw that. I can go have an equality check. I can have a key, which is the make, model, and year. I might need to make a special structure, an object, something that stores that, but I have a key that represents that. And then every time I encounter one of those, I have an integer. I get that integer, I add 1 to it, I put it back in my map. So we'll see an example of this in a second. So how could I find all the car makers and list all of their models? So what are all the models that a car maker makes? Well, I mean, we could obviously go look up at their website and say what are the ones they make. But what if we had just this list of data and we want to query it? And so from all the cars that are sold, all the cars that are registered, maybe I only care about all the cars in my state because I'm looking at a state database. What are all the car makers' models in that state? Well, we'll think about this. We'll come back to this in a second. What if I wanted to know all the cars that are sold in any given year? It's another way we can sort this out. So these types of questions can all utilize a map, but they might need other data structures to do that. So what I want you to do is I want you to take a moment, pause it, and think about that. And then we'll continue in just a second. We'll talk about each of these data structures and how they can be used. So I hope you did take a second to pause and think about that. Let's go through the first example I talked about already, and maybe you can come back to the other questions. So again, make, model, year, and VIN. How do I find out all the cars are sold in each year? Well, the first thing is imagine the data coming in. So there's a whole list of data. I have a Wrangler 2020, a Patriot 2016, a Prius 2015, so on and so forth. The data's coming in. Like we talked about, I create a map where the key is the year and the value is just 1, 2, 3, 4, 5. This starts with nothing inside of there. There's 0 there. But every time I see a year, I add a 1, and then I keep incrementing that each time I see another one. So it's a pretty straightforward data structure. The map is a key where is a map where the key is the year and the value is the integer count. All right. So how would I figure out what are all the car makers and what models do they have? Again, I have the same data coming in, the same list of data coming in. How do I organize that? Well, the car maker is the make right there. So it's Jeep, it's Toyota, it's Tesla. Three ones I showed you: Ford, GM, Fiat, Chrysler, whatever car maker you want to talk about out there. My data structure then, my key is going to be the maker, and the models is going to be all of the other items. But I need to keep multiples here. The Jeep doesn't just make the Wrangler, it makes the Wrangler and the Patriot. Toyota makes the Prius and the Camry and other ones like that. Tesla, Roadster, and other ones. So the key is the make. Could be a string, could be another data type inside of there, and the value is a list of all the models. All right. You could be specific. You could say a 2020 Wrangler, 2019 Wrangler, 2018 Wrangler if you wanted to. It depends on how you want to structure the data. But the map helps us to organize this data structure. So if I want from the map, I say, well, what are all the values that Toyota, what are all the cars that Toyota makes? I say, well, to the map, I say, get me all the values for Toyota, and it returns to me a list. And the list has one of each of these models, whatever type it is. So hopefully I have a little better idea. So try and answer this question if you didn't do it the first time, if you couldn't get it. How do I figure out from the make, model, year, and VIN number, how do I figure out all the cars offered each year? So what are all the different cars I could have bought in 2020, 2019? All the cars that people did buy. So take a second and pause it if you need. But remember, the data coming in is the same. So what does that map look like? What is the key? What is the value? It doesn't just have to be single values. It doesn't have to be just an integer. It could be a list of values. It could be a set of values. It could be a map of values. All right, so I constructed mine where I have the key is 2020 again. We saw that before. And now the values are a whole object, a list of entire objects, or maybe even better yet, a set of entire objects. If I create a set and the key to the set is some limited items inside of there, so the 2020 Jeep Wrangler, the 2019 Jeep Wrangler would be a different item. But now I can keep track of each one individually. If I want to know every person who bought a car in 2020, well, I could make that a list of full objects, a whole list. But if I make it a set, then I keep tossing one out every single time. So I can basically stack this with either a list or a set. And the list then would be, I would throw away everything of the, except for the name, the make, model, and year. But I could actually do it with including the whole VIN number if I just just change the key to that to just be make, model, and year and put it into a set. So there's a lot of power that the maps and lists and set open up in how I can really organize my data without having to write a lot of code. Just simply defining the key appropriately and throwing them into existing data structures opens up a whole new world for me to be able to sort, organize, and report on data. And so we'll play with that a little bit this week. We won't play too much with the details of building hash structures. They're not that difficult, especially after having built trees and lists. But how we use them is really important. It really opens up the creativity and power of how we can construct algorithms using these data structures.